This is the history of spaceflight and space technology. I'm Andy Chaikin. This is week 11, Space Shuttle and the International Space Station. Well, back in 1969, even as they were achieving the goal of Apollo with the first landing on the moon, NASA was already looking ahead to a new era in space travel. They were thinking about two of their most cherished goals: a permanent space station in Earth orbit and a reusable space shuttle that would take astronauts to and from the station. So this is just some concept art on the left that shows what the concept was for this shuttle station infrastructure, if you will, in space. And on the right, you see the early design for the space shuttle by Max Faget, who of course was the brilliant engineer who led the design of the Mercury capsule, was also very influential in the Apollo command module. Well, Faget envisioned a fully reusable shuttle that featured a rather small winged orbiter with straight wings and a rather small payload bay. I guess small compared to what the shuttle ended up being anyway. The shuttle would be carried to high altitude by a booster that was also manned and also had wings, and that booster would get the orbiter up to high altitude where it could separate and fire its own rocket engines to go into orbit. The booster, meanwhile, would fly back to land on a runway. So this was Faget's concept for a fully reusable space shuttle. In 1972, after much delay, Richard Nixon, President Nixon, finally approved the space shuttle program. And on the upper right, you can see the NASA administrator, James Fletcher, meeting with Nixon, and Nixon is holding a model of the shuttle that he has just approved. Now, NASA originally had estimated that the shuttle program for a fully reusable shuttle like the one I just showed you, that the cost of that program would be $10 to $13 billion. And in late 60s, early 70s money, that was a lot of money. And so the White House was not willing to approve a program that was that expensive. They insisted on $5.5 billion or less, and the Office of Management and Budget whittled that down even further to about $5.15 billion. Now, Fletcher would have liked to go with the more expensive shuttle, obviously would have liked to have more money to do the job. But, excuse me, he accepted the lower figure, partly because he realized he couldn't convince them to give him more money, but also because he was really passionate about the idea of a grand tour, a robotic mission to explore the outer solar system. So he was hoping that there would be enough money left over in the NASA budget to pay for this grand tour mission, which eventually became what we call Voyager, and did in fact visit the 4 giant planets of the outer solar system. But anyway, on the left, what you see is the shuttle that Nixon approved. It's less expensive in part because it is not fully reusable. Instead of a manned flyback booster, what you have are 2 solid rocket boosters that fire for the first portion of the trip up into space, and the orbiter has its own rocket engines, which are fed from an external fuel tank, which is also not reusable. The solid rockets you can pick up in the ocean and reuse them after you've cleaned them out and so forth, but that external tank is not reusable. So in doing that, they got it in under the cost ceilings that White House and OMB had established. Well, here's the shuttle orbiter that we know, and you can see it's a pretty large vehicle. That payload bay, that big cargo bay with the doors opening from it, is 60 feet long and 15 feet wide. And the reason the shuttle turned out to be that big was because in order to get political support for the program, NASA had to gain the approval of not only the White House, but the Department of Defense. The idea was that they would be able to use the shuttle not only to carry out scientific missions and launch satellites and retrieve satellites, but they'd also do a lot of missions for the military, launching and retrieving military reconnaissance satellites and so forth. And the military's big spy satellites dictated that you needed this big 60 by 15 foot cargo bay. The carrying capacity was upwards of 65,000 pounds, just an enormous amount of capacity for a vehicle like this. The length of the orbiter is 122 feet, wingspan is 78 feet, and it weighs 172,000 pounds dry with no payload, no fuel. And that's about the size of a DC-9 jet airliner. So this is a really sizable vehicle. And you can see in the illustration here that it has a manipulator arm that can be controlled by the astronauts to grab and move around big payloads like a space lab or a satellite or something like that. So that's the shuttle orbiter as we know it, as we have known it for the last 30 years. Now the question arose once they designed the orbiter, how do you get it back and forth from, for example, where it's built in California at North American Rockwell? How do you get it to the Space Center in Florida, for example? Or if it has to land somewhere other than the Florida launch site, how do you transport it back to Florida for the next mission? Well, a very interesting concept surfaced from an engineer at the Space Center in Houston, I believe. And his idea was to take the orbiter and mount it on top of a big 747 airliner. And he got quite a bit of resistance to that idea, but he ended up demonstrating that it really would work. He built a flying model of the shuttle 747 combination, and that ended up being what they approved, what they decided to do. And here you see a photograph of a shuttle being transported across the country on a 747.